Hi everyone, this is our second question from Analog Electronics. Here is the question. Consider that the given diode is ideal. The input voltage given is Vi equals 10 sine 100 pi t. The time duration for which the diode is forward biased during one time period is asked in milliseconds. So before we proceed, let us look at the prerequisites. So to do this problem, we must remember the quadrant table of the trigonometry, where in each quadrant it is specified which trigonometric functions are positive. So in quadrant 1, all the trigonometric functions are positive. In quadrant 2, sine and cosec are positive. In quadrant 3, tan and cot are positive. And in quadrant 4, cos and secant are positive. So this will help us a lot in solving this problem. So going back to the question. So here I am performing the open circuit test on this diode. So as per the circuit diagram, this is the negative end of the diode and this is the positive end of the diode. Let us consider this as the ground. Since this is an open circuited diode, there is 0 ampere current flowing through this resistor. That means there is no voltage drop across the resistor. So this Vi directly appears here also. So this is Vi, and as this is the ground, which is 0 volts, and this is a 5-volt voltage source, the voltage at the positive end becomes minus 5 volt. So for the diode to be forward biased, the condition is the voltage, the potential difference between the anode and the cathode of a diode must be greater than 0. So here VAK is VA minus VK, which is should be greater than 0. So here the voltage at anode is, that is the positive end of the diode is minus 5, and the voltage at the cathode, that is the negative end of the diode is Vi, which should be greater than 0. So this is Vi less than minus 5 volt. So let us continue. So here I have drawn the Vi equals minus 5 volt. So here we have got the condition for the forward bias of the diode, which is Vi is less than minus 5 volt. That means the diode is forward biased only in this region where the input voltage is less than minus 5 volt. So we are required to find the time duration, which is T1 minus T2, which are the points subtended at the intersection points of Vi is equal to minus 5 volt and this input waveform. So if we calculate T1 minus T2, that is the time duration which we are required to find. So before we proceed, first let us calculate the time period of this input waveform. So we have been given with the input waveform equation, which is 10 sine 100 pi t. So here it is of the form A sine omega t. So time period equals 2 pi by omega. Here omega is 100 pi by comparison. So the time period is in milliseconds. It is 20 milliseconds. So as the time period of this input waveform is 20 milliseconds, so this point is 20 milliseconds. This is 0 milliseconds. And this is 10 milliseconds, indicating the half time period. So now for finding this times Ti and T2, T1 and T2, let me equate this input voltage, which is 10 sine 100 pi t, to these points at which the input voltage is minus 5. So sending 10 to the other side, we get sine 100 pi t equals minus half. So we know that as per the prerequisite, sine is negative in the quadrant 3. That means the angle we must choose should be greater than 180 degrees. So pi plus something. We know that sine 30 degrees is 1 by 2. But here it is minus 1 by 2. That means it is 180 plus 30. As in the third quadrant, sine is negative. So I'm equating sine 100 pi t equals to sine of pi plus pi by 6. So we get equating the angles on both sides, 100 pi t equals pi plus pi by 6. So the pi gets cancelled. This is 1 plus 1 by 6, which is 7 by 6. So t is 7 by 600 seconds. So in milliseconds, the time is 11.66 milliseconds. That means this time t1 is 11.66 milliseconds. And we know that this point, which is exactly in the middle of the whole period of the input waveform, is 10 milliseconds. That means the difference between these 2 points is 11.66 minus 10 milliseconds. And this same difference, which is 1.66 milliseconds, exists between T2 and 20 milliseconds also, as this is a symmetrical sine wave. So to find T2 minus T1, we can simply, so this is 10 milliseconds and this is 20 milliseconds. That means the difference between them is 10 milliseconds. So from those 10 milliseconds, I am removing these small differences, which are 1.66 milliseconds, which comes from this point, and I have to subtract another 1.66 milliseconds, which comes from this point. So this is the answer we have to find. So T2 minus T1 is the time duration. So 10 minus 1.66 minus another 1.66 is 6.68 milliseconds. So this is the time duration for which the diode is in the forward bias. So this is the answer. Thank you.